Here we have another example for level measurements. Levels are recorded at a number of points A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, and Q. Initially, we record the level, a value of 1.183 at a known benchmark of 42.355 meters. And as we traverse our site, we have had to make a number of change stations, taking the level initially from station 1, moving it to station 2, then from station 2 moving it to station 3, and then from station 3 moving it to station 4, so that we can get the heights for each of our points recorded. We're going to calculate the heights by the rise and fall method. All our recorded values are given in meters. The first thing we're going to do with the rise and fall calculator is to remove the previous set of data. To do that, highlight the cells we have in green and delete. So we're clearing the back site, the intermediate site, and the foresight columns. We're also going to remove the reduced level, and we're going to remove all the remarks. So that gives us a blank spreadsheet to work with, and we're going to fill in values for back site, intermediate site, and foresight as we go through our example. We're also going to enter in our reduced level and remarks so we know which of the reduced levels relate to each of the points. Starting on the left hand side with our first measurement. Our first measurement is a back site reading. Value is 1.183. It's entered underneath the back site column. We know the reduced level for this point, 42.355 meters. Under remarks, we can enter in the comment of benchmark. Our next point relates to point A, and for that it is an intermediate site, and we can enter in the value of 1.423. The next point we have is point B. Again, it is an intermediate value, 1.770. Point C is an intermediate reading, 1.010. Point D is the last reading at the station, therefore the value is recorded as a foresight under the foresight column. Value is 2.010. The staff is held at position or point D. The level is moved from station 1 to station 2. Then the first reading taken at station 2 is cited back to point B. First reading is a backside reading and goes on under the backside column. The value is 0.909. Point E is an intermediate value, 3.806. Point F, again an intermediate value, 4.051. G is an intermediate value, 4.925. Point H is the last reading while the level is at station 2, therefore is a foresight reading, 0.890. The staff is kept at point H. The level is moved from station 2 to station 3. The first reading taken at station 3 is a backsight reading to point H. First reading for point H goes under the backsight column, 3.626. Point I is an intermediate reading, 3.042. Point J is an intermediate reading, 2.495. Point K, intermediate reading, 3.073. Point L is an intermediate reading, 2.819. Point M is an intermediate reading, 2.469. Point N, intermediate reading, 1.680. Point O, intermediate reading, 1.370. Point P is the last reading we take when the level is at station 3, therefore will be a foresight reading. Its value is entered in under the foresight column, 2.345. The level is kept at point P. The staff is kept at point P. The level is moved from station 3 to station 4, and another reading, or the first reading of the level, is taken back to point P. The first reading, 0.235, is a backsight reading taken when the level is at point or station 4. Then the last point recorded is point Q. It is the last reading taken when the level is at station 4. At this location, there are no intermediate readings, so we go directly from backsight reading to foresight reading, and that value is entered in as 3.336. All the values have now been entered in. After our values have been entered into the spreadsheet calculator, the spreadsheet will then automatically look at the values and between subsequent values determine whether the latter value is greater or lower than the preceding value, and hence calculate a rise or fall for that change in level. Here you can see the values for rises and falls have been calculated in these two columns. Using the initial reduced level or benchmark value we have, a fall value is taken off the reduced level and a rise value is added onto the reduced level so that we can calculate the reduced level for each of the points where we've recorded the level. Additionally, numerical checks are applied to our spreadsheet. First numerical check is to add up all the backside readings, add up all the foresight readings, work out the difference, minus 2.637. The next numerical check is to add up all the rise values, add up all the fall values, work out the difference again, and again we have minus 2.637. The last numerical check is to take the last reduced level and the first reduced level, and to work out the difference between those two values, again we get minus 2.637. These values, these three differences, are all the same, and that gives us confidence in our calculations that have been performed in the spreadsheet.